Alright guys, today we're going to be looking at what we call a normal distribution. A normal distribution would have been the second trial that we did yesterday where we rolled 2 dice instead of 1. First off, let's talk about what terms can we use to describe the shape of a data distribution. We talked about these before. We talked about uniform being straight across. We talked about unimodal, where it has just one mode, one peak. We talked about bimodal. We said skewed left and right for shapes. We also talked about it being symmetric. Okay. As far as a sketch for each shape, uniform looks something like that. Unimodal has just a single peak. A bimodal would have sort of 2 peaks. Skewed left and right are going to look like these. And of course, symmetric is just anything that can be split in the middle and look the same on both sides. Now, a symmetric bell-shaped curve is a curve where the mean, the median, and the mode are all the same value. Okay? So basically, it's bell-shaped, and then it would also be symmetric. Okay? A normal curve is one of these bell curves. Alright? Where the mean is the center. It follows something we call the empirical rule that we're going to talk about here in a minute. Empirical rule. And it's also symmetric. Let's not forget that part. Okay? So now, here's the important part of normal distributions that we're really going to talk about. How are we going to use these? First off, what is the empirical rule? All right. Well, I'm going to label this normal curve to show you the empirical rule. Basically, the first part is that within one standard deviation in either direction of the mean would be in the center here, I am going to find 68% of the data. Okay? Now within 2 standard deviations of the mean in either direction, I'm going to find 95% of the data. And within 3 standard deviations of the mean in a normal distribution, I am going to find 99.7% of the data. Now, well, what does that mean? That means that 1 standard deviation to this side would contain 34% of the data, as well as 34% of the data here. If we break this down a little further, that means that 13.5% of the data would be here, and 13.5% of it would be in this little region. Now this darker region down here is going to contain 2.35%. And this region over here is also going to contain 2.35%. Now, what does that leave us? Well, outside of this 3 standard deviation, in this direction there's a 0.15%, and in this direction there's a 0.15%. Okay? Now, how are we going to use this? Alright, so let's look at this. We've got a mean of 64.5 and a standard deviation of 2.5. So we're going to label the normal curve to sort of reflect this information. Alright, so how are we going to do that? Well, I'm going to start with my mean in the middle. My mean is 64.5. Okay? Then I'm going to take that 64.5 I'm going to add my standard deviation to it, 2.5, which is going to give me 67. So one standard deviation in this direction should be the value of 67. I'm going to add 2.5 again, and that would give me 2 standard deviations away. If I add 2.5 again, that would give me the number for 3 standard deviations away. And now I'm going to subtract 64.5 minus 2.5. It's going to give me a value of 62. Subtract 2.5 again, I get 59.5. Subtract 2.5 again, and I get 57. All right. Now, down here it says, what is the probability the random selected woman will be 67 inches tall or taller? All right. Well, if I shaded this to represent that, if I look at 67 inches, it's right here, and that's going to represent all of this, or taller is going to be everything out this way. Okay? So now if I take these regions, well, if we go back to our previous page, remember this part is 13.5%. This piece right here is 2.35%. And this little piece extending out here is 0.15%. So what I'm going to do with those is I'm going to take 13.5 plus 2.35 plus 0.15, add those up, and I'm going to get 16%. So I can say 16% of the women would be 67 inches or taller. Okay? Let's look at another example. Alright. So I've got the walleye fish, normally distributed. The mean is 8 inches for these fish, and a standard deviation of 0.6. Okay? So let's label our graph first. So we've got a mean of 8 inches. Okay? Standard deviation of 0.6. So I'm going to add 0.6. I'm going to add 0.6 again. And then I'm going to add 0.6 again. To go the opposite direction, I'm going to do 8 minus 0.6 gives me 7.4. And 7.4 minus 0.6 is 6.8. And then subtract 0.6 again and get 6.2. Now, what my situation up here is telling me is that we can only keep if they are at least 7.4 inches long. So it's saying what percentage can we keep? Well, let's look where 7.4 inches is. They have to be at least that value. So they're going to be anywhere from this region, and we're going to keep going. It's going to be anything above that 7.4. All right. So if we take these values from our initial chart, that's 34%. This is 34%. This is 13.5%. This is 2.35%. And this is 0.15%. Okay. So we're going to take all those values. 34 plus 34 plus 13.5 plus 2.35 plus 0.15, and we're going to get 84%. So to answer our question, we can keep 84% of the fish. All right. So let's look at a couple of closure questions. All right. Do the percentages in the region stay the same on all normal curves? The answer here is yes. And the simple answer is because of that rule we just talked about, the empirical rule. It's always those same percentages in those regions. Now the total area under any curve, if we added up all those together, you would actually find this. The total area underneath that is 100%, or you just think about it as 1.00 if we're writing it as a decimal.